people on YouTube are probably about to be a little bit disoriented because this is the portion that's actually going to be pushed up and not the other portion. I just had to fix up some sampling rate issues. I think they should be solved more or less right now. That flicker is actually real, though. That flicker is going on over here, and that's because we're redrawing not every frame, but I think basically every update, which is not great, but something we'll figure out later. Yeah. For the record, Shane, I cannot fix this live. I have to do this, I have to take the stream offline in order to fix the video stream like that. So, what was I going on about? Last week, we created the this separating axis approach to detecting collision, at least in 2D. Why is this so slow? You know, something weird is going on, actually. It shouldn't be this slow. And it definitely shouldn't be saying collision when there's not a collision. We had this working last week. I swear. So it looks like we're going to be doing a fair bit of backtracking. Wonder what's up with that. So let's go ahead and do that. So first off, we have to go back and fix the convex hull algorithm. And that's the thing that stretches a boundary around the points that we projected down on that 2D plane. So just to demonstrate that it's not working the way it should be right now, let me switch around to these vertices. So there we go. This is 100, 200, and then this guy will be 50 and 150, I believe. And Sigwin will have to cooperate at some point. Oh, my computer's actually struggling trying to put out this 1080p thing. That might be an issue. Okay, so clearly the convex hull algorithm is not doing its job. Although it appears that the collision detection is working as desired, as if these connections weren't actually there, which doesn't really make a whole heck of a lot of sense, really. No, I guess it does, because the projections are based off the points and not the lines. The lines only define the axes on which we draw the projections. So, for some reason, just switching around those 2 points managed to make the collision kind of work again, while also, I suppose, made it so that the convex hull is not being drawn correctly. So, the first thing I want to fix before anything is fixing that convex hull so that we have the proper separating axes being drawn to test against. And I'm wondering if there's a way to do this screen update without making it really stupid. Okay. So, what do we have? Okay, this is our test function. We got our... So that's just the header file that's separate, or that's defining it. And we have, okay, separate.h, that's what we want. So we have the number, we have our field structure, tells us the number of points, the vertices, and the connections. This is what we did, I think, like 2 streams ago. So the connections should be written in order, from the leftmost point as the first connection, followed by all the preceding points that are connected clockwise around the outside of this thing without creating any concavities, which is why it's a convex hull. So first we go over the top, then we go around the bottom in a clockwise fashion. And if we manage to get to our beginning point early without having to backtrack or retrace or what have you, then we should be able to say that none of the other points are part of that convex hull. They're in the interior. Okay, so let's find out how we're actually doing this. This cross product looks like it makes sense, so let's do that. This unit normal, there we go. We have a normal and a scaled unit vector. I forgot to write an explanation for this. Let me go ahead and make sure that's in there. So required in case projection. Oops. Projection is very high in both X and Y. Because remember, we have let me see. Worst case, square root 2 times max fixed. So we have fixed numbers and they have a maximum minimum range, but if we have a fixed number going maximum range in one direction and then the other fixed number in the perpendicular direction, like X and then Y, both maxed out, that's going to be a problem. So when we try to do math on it, we'll end up limiting our travel. I keep seeing people pop back in and out of the stream. We're bouncing between 3 and 5. It's weird. I mean, if whoever pops into stream, go ahead and say hi, so I know you're not like an android, robot, whatever. So what's next? So I'm trusting that code for now. I'm assuming whatever comes out as a unit comes out as a unit because we're dividing out the magnitude first, which makes sense. And then our scaled unit is dividing out 1.5, which is bigger than square root 2, and that just gives us a kind of like a squeezed projection, making sure that any projection we do at any angle is going to fit within our boundaries. So, projecting 2D points on a line defined by scaled normal. There we go. This is project 1D. This is what we're using to project the points. I don't think there's a problem with this quite yet, at least not that I see, and I'm pretty sure we validated it last time. Separate 2D, that's a whole thing. Check to see if value is already in the list. Let's see. Well, I mean, the logic checks out. This is simple enough. We have value, we have a list to check against, and then we have a pointer to a value. Let me see. What's this pointer do? Oh, it's just an array. Okay, so we're checking against an array. Up to the length of the array. Okay, that makes sense. Hey, we got 5 people again. Whoever's coming into stream, say hi before you disappear. Okay, we have find the extreme. Min or max coordinate. Okay, this checks out. So if we're not looking for max, then our max, if we're looking for min, we want to start out at fixed max and then work our way down. And that's what this number, I believe, is. Let me just label that. Fixed max. When you find out your code's not working, one of the best things you can do is start commenting basically every line until you find a contradiction in the logic. Because then you'll find out, you know, here's something I did that's obviously wrong, or an assumption I made that's incorrect. Okay. Sign mod. That's just something you multiply from in order to get sign out, so I can compress the logic there. Let me see. Extreme. Okay, well, I'm treating extreme as an integer and flipping this. That's just flipping the sign, so I don't need to do anything special with fixed conversion. Let's see. So we have extreme dex. That's what xdex is. And if we find something that extremizes it, 2 times I. So are we? Oh, okay. So we know this is a 2D field. We know the vertices are 2D elements. So we're iterating over 2 in order to find the extreme. This is okay. This is only for x values, which is why that's there. That makes sense. So we evaluate the x value of the vertices based off of whatever vertex we're on, starting with 0. all the way up until the number of points that we have. And then we're multiplying through by sign mod to flip it if we're looking for a minimum. Okay. And if we find something that beats our current best, we record that. And then we record the actual value of it so that we can compare against it. That's the thing, though. Oh, okay, so instead of doing... Yeah, the sign mod is tracking like that, and then this will track the same way it would have otherwise. So we're not tracking the... Wait a minute. Actually, I think we are doing something wrong here. Let me think. If we're looking for a minimum, we shouldn't have to flip our extreme. We should just have to flip our sign mod. Because otherwise this and this will cancel each other out, I think. Unless that's... Is that the point? So, let's see. Okay, first let's go under the assumption we're looking for the maximum. So we're skipping this and going straight here. Sign mod is 1, xdex is 0. The extreme value is the most negative we can get affixed. So the first thing that we find for essentially I equals 0, it's the first thing we find in field verts. That gets written to extreme, and we retract that as I equals 0, and then we're going to keep going. So this checks out with a positive. So if we are looking for the minimum, the extreme is now the most positive fixed value we can get. And sign mod is -1. So then we're going to do the same thing. We're going to find the value of wherever we're at. And sign mod -1 times... We've already flipped this. So that's going to be positive. So we have essentially accomplished nothing special here. This evaluates the same thing. If this is greater than positive, -1, so if this is greater than the most negative fixed number, when I feel weird about this one now. Okay, well the sign mod's over here, modifying this, so actually that kind of checks out. So it's just like checking for a maximum after we flip the axis. So then, write the thing, and let's say we get some value. Let's call this value, like, let's say the first value we find is 1. So then the first thing we can check against is 1. So that means when we go through and check against the next point, let's call it 0. Okay, so when we write 1, that's going to turn into -1. As long as -0 is greater than -1, it will check out and get written, and that checks out because we want 0 less than 1 to be written as our minimum value. Okay, so the logic tracks here. This should work. So I'm happy with this. Okay. Convex hull max angle. My god, okay. And this will get plugged directly into the convex hull itself. So, in all likelihood, problem is somewhere in here. Let's figure out what's going on. Okay, we have our field 2D. It's called shape. We have an index, and we have a boolean to check whether or not we're going backwards. So for right now, let's assume that's false and we're going forwards. So we're looking for things with a greater x value than what we're at. Okay, so where are we at? Data adjust. Okay, so this is yeah, it did prevent a wraparound. So I'm trying to remember how the angles are actually stored as a because I want to double check this now. Really, I want to double check everything, make sure I'm not making a stupid mistake somehow. So let's actually look in the reference manual and see if we can't find how they define angles. You go all the way to the bottom and check. Okay, 0 to 360 is expressed from 0 to f of that value. So according to this, we are mapping from 0 all around to 0. So our branch cut is from 0 to 2 pi. For some reason, I feel like that doesn't make a lot of sense. I don't know why. It seems like somehow the branch cut is different for me to do this. Because otherwise, I can, without the theta adjust, I can just do whatever angle, like the maximum angle. I mean, either direction, if we were going from, the branch cut was from 0 to 2 pi, we wouldn't need this theta adjust here. I don't think that would be necessary. Negative wraparound. So, let me think. Well, I guess if we're starting on our leftmost point and we're checking every point to the right of it, we could potentially have a negative angle, but that negative angle would get mapped as a very positive angle. Okay, that's probably why. For points below, for dy less than. For dy less than 0. And basically what it's telling me is if I have a point that's really high up and I'm checking the next point and it's below me, it's not going to look like negative 10 degrees. It's going to look like positive 360 degrees or 350 degrees, which is why I did that. So this is 180 degrees. So we're starting by saying what? Okay, so first off, what's the worst case scenario we can think of that we're not even going to check? We're only checking points to the right of us. So we're only interested in points from negative pi over 2 to pi over 2. So if I add pi over 2 to that, that'll be sufficient. If I add pi to that, which is what 180 degrees is, that will map the space from pi over 2 being the smallest or the lowest angle we can get, and 3 pi over 2 as the highest angle we can get. So really, what we want is to be able, at least going from left to right. So going forward, we want to find the highest angle up to what we'll evaluate as 3 pi over 2 or 270 degrees, and that's going to be essentially a point that's vertically above us, which is like if we had a square, which is what happens. We found out that in the model, in the game, it's not even a game yet. Basically, when we run the code, the square seems to work. When we change the position of the square, that's when we start coming up with some issues. So, we also have the problem where the triangle didn't even want to draw its bottom leg, which didn't even make a whole heck of a lot of sense. So what we need to be able to do is say we should be able to check our original point. So we need to write what our original point is first and foremost, and then we need to be able to go from leftmost to rightmost to the point where if nobody is on the same level as where you're at, then you're pretty much, or if there's no positive dx. So we're going from left to right. I feel like a picture would be easier to explain this. So let's go pull up that convex hull image again and see if we can find it. Oh, there we go. Wikipedia actually has a decent. Let's view this image. Oh, is this not popping up? Hmm. Well, that's weird. That is unfortunate. I used to be able to pop things up in here. So can I can't show what's in front of that window anymore. Okay, I'll fix that later. Wait, can I, at the very least, can I use paint? Oh, I can't even use paint, can I? Something changed with OBS, and now I can't show off any other programs besides the one that's labeled. Huh. Let me add in a browser window thing here real quick. Let's see. Capture a window. I'm using Firefox, so let's capture Firefox. No, not Paint. Firefox. There we go. Should try it. Nope. How's that? Yeah, I'll call that good enough for now. So this is what we're trying to do. Can you see the mouse? We cannot see the mouse. All right. Close enough. So let me just lock these things down real quick. So what we're trying to do here is create the convex hull. So I'm talking a lot of math, but what I want to get across is that if we see that leftmost point, that's going to be like our starting point. And that leftmost point, we're going to check against every other point. If we check the points that are above it, like the first point is connected to, that's going to come out with a positive angle. If we check the point below it, it should come out with a negative angle if we're kind of thinking about it in a way that's useful to us. But the branch cut inside of SGL is from 0 to 2 pi, which means going below where you're at is going to end up with an extremely high angle, not a negative angle. So we add that 2 pi to ensure that everything that we measure to the right of us is going to end up somewhere between 90 degrees and 270 degrees, or between pi over 2 and 3 pi over 2. So essentially what that's going to give us is that it's going to ensure that whatever the actual highest angle is, that's what we're going to end up doing. That's what we're going to end up connecting to. And that will work going all the way to the right. I'm thinking maybe there's an issue with detecting where you need to end up with, which is why that last point, like there's some sort of preference for the initial point. So when I move which point is the initial point, things get weird and it doesn't know to connect the initial point that we have. So the first point in the vertices array is not necessarily the initial point. If they aren't the initial point, then that appears to be where one of the problems comes from. The other problem is the fact that I can't even finish drawing the triangle, which might also be related to the fact that the first point in the triangle might also be the first vertex in the list, so that initial vertex point, being the initial connection, might not allow us to draw all the way around it. It might stop one before, which is what it appears to have done for that square where we flipped around those 2 points and made the leftmost point not the initial point. Okay, yeah, I'm talking about a lot of stuff, and yeah, the mitochondria happens to be the powerhouse of the cell. But what I'm doing is I'm trying to figure out if I'm doing something wrong here, which I might be. So this is just finding the max angle, and I feel like I agree with all this. So I have 3 checks, and I've got this little flag here. If I'm going backwards, that problem where I said where the negative angles become highly positive is no longer an issue, because when we're going backwards, we're looking for, I believe, the... now I'm trying to think. We're looking for the... Now I'm wondering if this is wrong because of this backward direction. If we're going backwards, we're still measuring the angle from the forward perspective. Well, yeah, the picture is... picture, I guess, can be interpreted as a cell with some sort of weird osmotic pressure happening to it or something. So, looking at these checks and looking specifically at this backward check, the backward check appears to be where the problem is. I think that might be where the culprit is. So let's first try to figure out if this thing checks out. No pun intended. So we want to know if... in list. If not in list. Okay, let's go back and check. Check this value is already in the list. So we're going to see if... What's the number of points got to do with this? The length of the list. Okay, so we have a value, the length of the list, and the actual list itself. So this is telling me that we're not checking the final connection. So what we should be doing... let me think. We don't want to go backwards, but I don't think that's a real issue, because the delta x is not allowing us to go backwards to begin with. Delta x is greater than or equal to 0. So delta x is ensuring that we're at least staying in the same place. This first check is not letting us go back to the initial point on the backwards run. However, this guy, this OR statement, should allow us to go back to the first initial point. So, if... So this should work. I don't know why it doesn't... Okay, let me check this out real quick. Oh, okay. A crucial step toward cat girls. That's definitely an odd... Thing is, Elon Musk has long since given up on caring about what he says or who reads it. I mean, I'm sure there's a way to do body modifications to make yourself look like one, but it would not go out well. I mean, there's people that get those injections and give themselves horns and split tongues and stuff like that, and so they definitely don't want to be employed anytime in the future. So they're pretty much committing to sustaining themselves off of welfare or their own private business. I don't think anyone's gonna be hiring cat girls. I think if anyone actually managed to genetically engineer cat girls, it's got to be a social problem. I don't know why we're talking about this. This is stupid. Okay. Let's try to figure out, because it really does look like my initial connection. So j equals 0. So there's got to be some interplay between j equals 0 and connection 0. Connection 0 should be... Essentially, it should be written by... Here, let's go down here. This is actually where it's going to get written. So we're going to find the extremes, the minimum, maxima. I trust this works. I trust that this makes sense, because the results kind of make sense. Let Let's see. Wipe connections and set initial. Maybe setting all these guys to the same actually existing index, so this might actually be a problem. I'm not certain. Okay, so the initial connection is going to be whatever the minimum X is. And if we have multiple minimum X's, we'll just, you know, end up with one. But then all the leftover connections will also be set to that. Is that actually going to be a problem? So we're breaking in the case we hit the maxed X. Oh! Mindex. Here, I think this might be the culprit. We're checking against Mindex, but Mindex should be equivalent to the first connection. And the first connection is what I was about to fix it to. So maybe that's not it? I don't know. I is less than less than or equal number of points. This feels wrong. What's the size of number of points? Or verts and connections? So verts and connections, I believe, are supposed to be the same size. Yeah, so I cannot be allowed to go all the way up to... There are a number of points elements. Oh, thanks, Zero Pants. I was waiting for... people keep popping in and out of stream, and I was waiting for like someone besides Shane to actually speak up. I can't tell if that 5 going to 4 was you leaving or not, but I trust you're around. But thanks for the encouragement. Anyway, so the number of points should be the number of elements in both vertices and connections, and, well, let's double check. How are we implementing this? Because I'm treating it the same. I'm treating it like they should both have that same number. So, first off, I don't think this is a good check. I think this should be strictly less than. Especially if we're starting with I++. I don't like that at all. Huh. Let's see. So there's just this weird disparity here between going from low to high. We have a for loop starting with index 1, which we're going through the connections, so it makes sense that we're going in order. But then we're tracking I, and now I'm iterating like this, and I feel like this could be rewritten. First off, for connections not equal to mindex, no matter what, for the bottom hull, something has to be written. I don't think I can accept that no bottom hull could be written, because except in the case of just literally 2 points, there has to be something. So what ends up happening, I think, is that in the case of the triangle, I++ managed to iterate directly to the last possible point, which was the same as mindex. I think this is a bad check. Let me try doing this. So for I is equal to I, I'm not going to change the value of I, and then we're going to do the same logic here. We don't need to iterate at the beginning of the loop. I believe this iteration is already happening at the end of this loop, so where we're starting is good. Connections. Okay, we're finding max angle. So probably max angle still works just as well. Yeah, okay. I'm trusting that this works just as well. And we're finding the maximum angle from the previous connection to right to the next connection. And that checks out. And if this becomes equal to our starting connection, then I'm prepared to break. Let's try that. It's really weirding me out that all of a sudden... I haven't even updated OBS. At least I don't think I have. I updated the... I switched over to Streamlabs real quick during the test stream. That didn't work out. But I used to be able to show you guys all my status screens and what have you. Oh boy. See, now you can see it. Now you can see all this stuff happening. I think something weird is going on with Windows. Capturing different stuff. I don't know. It's weird. Okay, I broke something. That happened. So definitely worse behavior. So first off, why am I not going all the way out to the max dex? Why is this thing connecting over to the end like that? Let's try to fix that. Okay, what is the issue here? So the top hull is not even finishing writing for some reason, and I don't recall ever even changing anything up here. So it should be able to hit the max dex. Did find X extreme somehow break? Is it not able to find the most extreme value? If max is true, we skip this check and we go directly to here, and we're literally just checking every X value. It's actually a pretty simple loop. It's just whatever is in the X portion. If it's greater than our extreme value, which is negative, the most negative number we can get, we write the new value. So this should be it should be basically trivial. So I'm not sure if I believe that the max dex is not being found. In fact, I'm so sure that let me just try to write in a check here. So find X extreme. Okay. Let me set up a redraw flag. Maybe I can stabilize this a little bit. Redraw equal false. Okay, redraw equal true. What I'm doing here is I'm just adding a redraw command so that when I do an input, things redraw, but if not, it doesn't necessarily have to redraw, because I think I'm redrawing way too often. If redraw, because that's that flickering that I don't like. There we go. Okay, so now what was I actually trying to do? Well, I was trying to add a print statement that printed out the maximum, the index of the maximum vertice of Well, really, either of these guys. So I'm just gonna add that at the end. So, print tests. You know, what I think happened is previously my stream might have been outputting at 720 or something like that. I'm not certain. I'll have to check the YouTube and see if the resolutions were like that. But I'm noticing a tiny bit of slowdown, and it's kind of weird. And I don't know if it's because maybe I activated Aereo when I didn't need to or something. Okay. But also, the Mendefin is acting up a little bit weird. So I think maybe when we were doing that test stream stuff, when we were trying out Streamlabs, I screwed up something. I don't know what. So SL print FX. Let's locate it out to lines 1 and 2, or just everything on line 1 is probably fine. Locate line. This is line 1. Okay, and then we're going to fixed the max dex that we're going to find. So there we go. Wow, this is a mess. Okay, we want fields 1 and 2. All right, field 1. Let's do the minimum and the maximum. So this is going to be false. And then a little bit later, it's going to be true. Then we're going to do the same thing again for the second field. On line 2, I believe. So first off, let's go back up to where we define these guys. And then we're going to check to see which... Oh my goodness. Incompatible type. What is find x extreme? It returns an integer. Okay. It wants a field. Returns an integer. Do I need to... Oh, maybe the thing I'm sending it. Do I need to put like an ampersand there? Make sure it's a pointer. That might be it. Oh, come on, Sigwin. Yeah, it looks like that was it. Okay. So the first field is, I believe, the blue shape, and the minimum index is 0, maximum index 2, and then the red field is the second line, and that's the second field, and that would be index 2 and index 1 for minimum and maximum. We're saying point number 1 should be the one with the rightmost. Is this actually working right? No, it doesn't look like it is. Probably because, yeah, these connections are probably, yeah, the connections are definitely wrong, so obviously the collision can't possibly be right anyway. So, we found out it was 0 and 2, right? Oh, was it? No, it's up here. So, Mindex should have been 2. Max dex should have been what? 100, 1. Crap, I already forgot what we got. Let's rerun that. Okay. So for the first shape, what do we expect? We expect Mindex to be the 0.1, not 0.0, right? Or actually, no, they're both identical. Sorry. Here, let me drag this over in a convenient manner so you guys can see. So now if I click here, oh, well, that's a little bit low. There we go. Okay. So we find field 1, we have Mindex 0, max dex 2. Does that check out? Mindex 0, yeah, 50 is the lowest number among the x's. Max dex 2, 100 is the highest number. So these are acceptable results. For second field, 2 and 1. Mindex 2, 50. Yeah, that checks out. And 1 for 200, that checks out. Oh, wait. 150. So that, sorry, this is a Y value. This is the X value. So 150 is the highest of the X values we have present. So that checks out. So it looks like at least we're finding the right extreme. Oh, 6 people on stream. Whoever's here, go ahead and say hi so I know that you're alive and real. I mean, I prefer at least alive. I'll take fake and alive over real and dead. Okay, anyways, so the extreme finder seems to be working right. So then why are the connections not being drawn right? So we need to find out, well, again, we come back to the convex hull. So I think we have to try to reconcile the idea that there are multiple identical extrema, but that's not even the problem for the red shape. The red shape, there's a unique minimum, unique maximum. For the blue shape, there isn't. Both of them are not working. So both of them have some weird issue where the max dex does not appear to be doing its job. Huh. You know what? I have an idea. These two, I believe, can be combined. So let's do that. Let me block comment out some stuff. Okay. So here's what I'm going to do. Oh, let's this too. So in this, we're doing a single for loop. We're starting from low to high, and then once we hit a connection being equal to the max dex, what we can do is change theta adjust, convex hull max angle. Oh, we need to track this as a flag. So this. So false, what does that signify for this function? False signifies whether or not we're going backwards. So false meaning we're going forward. So let's get our own boolean in here called backward equal false. So we're starting forward. All right. And then if we hit the max dex, then we can actually start going backward. Oh, okay, what did I just do? Okay, we don't actually need a break statement here. So, we're gonna keep doing this backwards then, and it looks like we're basically identical. So at the very least, we're kind of compressing the for loop logic here. And maybe that'll help. Maybe there's something getting lost in translation between I equal 1 and in the first loop and the I equal I in the second loop. If we are on the actual initial connection, then we can break. So, So convex hull max angle, connections I. So we're just looping through connections. So I'm thinking if there's a way to use I creatively, and I'm not seeing it. All we can say is that once we've reached a connection that is identical to the one we started with, then we can break out. And I believe this probably won't fix everything, but it might help. Okay. Well, it looks like we're basically back where we started. Well, at least the collision works better. We still have what appears to be an issue between the initial point not wanting to connect to the actual thing. So here's what we need to do. I am going to print out the actual connections for field 2. So we want to see why this thing is connecting back into itself after it's already made that connection before. And this thing will break itself out if we hit the number of points anyway. So by the time we get to the last one, it will, the drawing function here, I believe, should automatically loop back to the initial if we run out. Yeah, draw the last connection. So the last connection will just be drawing the last one to wherever he started. So that makes sense. Okay, so print statements. I think these are now kind of redundant. We already know these things are working, so we don't need to print them out. Let's now print out every connection for field. Was it 1 or? Hey, Lieutenant Commander Data. Okay, well that's not how you spell Commander. I'm not sure if you even spelled, well, maybe you spelled Lieutenant right. I didn't see it quick enough. You definitely didn't spell Commander right. And now I'm questioning whether or not you're a robot and or android. But thank you for the follower anyway. Okay, what was I doing? I was finding the connections for field 1 or 2. Okay. Sorry if I offended you. I'm still not sure that Lieutenant Commander is spelled to regs, at least to a terrestrial navy. I don't know if a space navy might have a different spelling tradition there for that. Okay, connections. Which one of these shapes is the one that's obviously wrong? It's field 2. Field 2 has connections 0 through 3. Let's write those. We fixed. We don't need to find the extreme anymore. What we need to do is we need to find field connections. How do we address these? Where are we at? I know we addressed these earlier. Field connection. There we go. That. I like this. Let's try that. So field 2 connections, do 0. Then we can just keep going through all 4. This song is just barely rubbing me the wrong enough way for me to change it. Let me see what it is. It's probably some PSU stuff. I always, yep, it's every time a song just feels weird to me, it's always PSU. Then yeah, every stream my playlist shrinks. Okay, so we're printing out all the connections. Let's see what is going on with these connections. There's something wrong with my logic in the Convex hull program, but I'm hoping it's a quick fix because I kind of want to try and get started on 3D projections down onto 2D planes. Because that's kind of like the penultimate step for making this algorithm actually work in 3D. So we start with point number 2, we move on to point number 0, and then we go to point number 1, and then point number 3. This all checks out. Why is the last connection not drawing correctly? Am I making a stupid assumption? I think I'm making a stupid assumption, guys. And I think it has nothing to do with my algorithm. I think it has everything to do with this test function. When I draw the last connection on field 2, am I drawing to connection 0? I certainly hope not. So, let's see. This is really hard to track. Okay. So we're gonna find the vertices, field 2. This is the, what is this? Draw the last connection. Okay. I believe that we're drawing the last connection incorrectly. Well, let's double check that. Let me just double check the order that we're doing it. We went, let's see. We should be going from number 2 to, I believe, from 2 to 0 to 1 to 3. And I believe that's what we had. And this last connection for, there we go, number of points to 1 should go to, see? We're drawing to verts. We're drawing to the first element of verts. We're drawing to the first point that was written in the verts, not the first connection. Okay, so this is fixable. This is perfectly fixable. Instead of being 0, it should be connection 0. It should be the first element connections. So this is a drawing problem. This is not the first time that my logic problem was a drawing problem. If you recall, for that 7-hour ridiculous stream that we did for, what was it? What was I doing for that 7-hour stream? Was it just Convex Hull? It was the same freaking problem where I was debugging for a few hours just looking for something wrong in my logic when it was something wrong in my drawing function. See, I already fixed it up here too, so that was just negligence. Oh, come on. So let's see. Just Sigwin's constantly giving me crap. There we are. So I believe that should have fixed that. Okay, I'm okay with this. Oh, forgot to fix that one thing. So that appears to be working. Inside of the test loop, I wanted it to only draw when I have an input. So once I redraw, I'm going to set redraw to false. I forgot to do that. And now let's also get rid of one of the points for field 2. So field 2, let's turn it into a triangle and see if we can actually get that let's get rid of the bottommost point. This point right here. Let's get rid of that and get rid of this. Let's try that again. And I think this will be, oh come on, Sigwin always. I think this will be the solution that actually fixes the apparent problem of not being able to draw the convex hull right. And there we go. Triangle is being drawn correctly. And I'm only redrawing when I'm moving, which, I mean, obviously there's a better way of doing this. I'm sure I should program something that does it better, but, wow, even... So the collision feels nice now. So with the collision feeling nice, and I think I've made some minor changes to the convex hull that would actually fix the other problem I was having. So right now the entire box is moving, so all the vertices are moving the same way. If I change it so I'm only moving one vertex, so that we have a triangle base for collision, by making one of the other points on the square internal, that was giving us problems last time. Let me see if I can get rid of that. So where do we change? Okay, here's a reset. So let's multiply some stuff by 0. We're only changing the first guy, so let's just 0 times. That way I can set it back by putting a 1 there. It's a nice quick fix, I hope. Only took me, what, like an hour or so? Record time, I think. All right. Oh, that's definitely weird. Anyone else notice the side stuff? What's up with that? That's new. I think that's a Joe engine thing. I don't think it's something I have to worry about. Oh. Oh. Oh, we still have this weird behavior. Why do we have this weird behavior? We shouldn't be detecting this collision. Not colliding, not colliding. Not colliding, colliding. So this thing is not finding a separate access for us to collide against. See, this one makes sense. However, wow, I do not like this music. What's going on? So why is it when I'm coming this close, it's detecting a collision? And it only seems to be... Oh, no, it's not even... Yeah, So, how am I not getting a an independent collision here? The normal... There are no normals. I don't think there are any normals that will actually go in between these faces. And it's still detecting a collision even all the way out here. That's very odd. It's stuck on detecting collision. I can't even get a situation where it won't say it's colliding. What's up with that? Actually, it feels a little bit slower now. I feel like there's something changed in the program. Something's weird. Colliding. It shouldn't even be colliding here. I'm back at the default, and I should not be colliding. What is going on? It's a weird problem to have. Let me restart. Not a fan of this as background music. I think this is going off the playlist as well. What is this? Close enough, whatever. Okay. So we are not colliding. At least we claim not to be colliding. So then let's start moving. Now we're colliding. Now we're not. Now we are colliding. Now we're not. Collision, not colliding. Collision, not colliding. Is the fact that I can change this... Like... What? Okay, why is this colliding? I believe it's because I don't have a separating axis between these two guys. But, for some reason, we really should have a separating axis. Let me hold on to this for a minute. And let me go over to the browser. Let's go back and try to look at that, that graphic here. So, where's... There. Okay, so this is the graphic. Let's just try to zoom in a little bit on that one. Well, this is a graphic. It's not the graphic. So all these lines that all these axes that we're testing against, are they normals or are they parallel? So this one appears to be parallel to this line, or the bottom. Oh, sorry. Can we not see that on here? Let me try to raise this up a little bit. There we are. Okay. Okay, so we have a let's see. We have the object B here. We're testing against oh, we can see my mouse. That's nice. So we have this line, I believe, is being projected. Where is it being projected? Is it this here? I'm not sure. Okay. And this line here appears to be just a projection of this line here. This line here, I'm honestly not sure, because it looks like it could have been this line here, but it might not be. It could also be the normal of what? This guy? That's the thing. How do you Because maybe the separating axes I'm building are not sufficient. I need to either try more axes or I'm doing the wrong thing. I'm testing against the normals. So let's try to figure out how to build these axes. Because maybe my separating axes themselves are not working correctly. So here, these guys managed to find a separating axis, and it's not even it's not even something that's relevant to any of their shapes. So how do you know which separating axis to try? So maybe one of the separating axes I can. Oh, I do not like this. This background music that's going off. Close enough. So one of the separating axes we can try. Here's a separating line. We need to figure out if there's a way to just draw some sort of midpoint, I guess. So, from center to center of the two objects, we can draw a line, and then we can draw a normal... Well, I mean, even if we just draw the line should be sufficient. Because the line between this shape and this shape from center of mass, I believe, would allow us to get something like this, but I'm not certain. So the problem is constructing our separating axes. So this guy, this is the reference we keep coming back to. The what's going on with the separating axes? How is he testing every axis, or how is he defining every axis rather? The normals of each shape's edges. Okay, I believe that's what we're doing already, though. Yeah, this is already inside the code. So let's go ahead and close out of Mednafen real quick and just go back to the code. Where's my separating axis there? Convex hull. I'm satisfied with convex hull. I believe that's working. Find X extreme. I believe that's working in list. Separate 2D. There we go. So when we're creating the lines, how are we creating these lines? Unit normal. Okay, first we're getting the normal. So we've gotten the normal, and then what we project using the scaled normal, which is we're getting from the unit normal function. So let's go back to project 1D and see how that works. So we appear to be taking the inner product of the normal with these guys. So we're testing along the normal where these points are going. So that checks out. And then unit normal, we're just getting, essentially, there we go. So, minus dy dx, that's the slope we're getting, so, or minus d, what is it? Yeah, minus dy dx for x and y coordinates, that makes sense. So that's what's written over here on this, so we are getting this perpendicular, this normal. So we get the two list of axes to test, and if we go to our code, I believe, not project 1D, but separate 2D, we have each line segment on field 1. Okay, there we go. So we get the normal from field 1, blah 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 blah. We do the same thing for field 2. So yeah, we're doing the checks on both fields. That checks out. Okay. Projecting on the axis. Oh, this is for if we wanted to stop it from doing something, but that's we're not doing that quite yet. Oh, that should already be handled as is. If you're inside another thing, then that's already a collision, and for us that's good enough. The problem is I don't know that these the normals are sufficient to detect collision properly, because it looks like we're able to get close enough on an odd angle if we don't have a flat normal between them in order to not detect the proper collision. So how do we fix that? How do we know which normal to test? So what we can do is we could make 2 additional checks. We're going to do whatever the... Now this is going to sound very expensive, but I'm thinking we test each point in one field against each point in another field and find out which 2 points are the closest. But even that sounds wrong. So, assuming they're not overlapping. If we assume they're not overlapping, the 2 points that are closest are the points that are closest to being within collision. So then we can draw a vector between them, and then we can draw the normal to that vector. And that can be our... Actually, if we just draw the vector between them and we project onto that vector, that in itself should be our separating axis. So, in that case, I think one additional check might be able to do it for us. Except, I don't know that would actually help us in this situation. So if let's go into paint. Can we actually see if I'm doing paint right now? It doesn't look like we can. Nope, it doesn't show up here. Doesn't show up here. Let me make another one of these, or just kill, so I can actually show you what's going on here. So we have let me get you an actual paint thing on a window capture. Come on, man. paint. Oh, there we go. It automatically knew what to do. It's nice. Okay, let me just kind of squeeze this up a bit. No, wait. No. That's not what I wanted. There we go. Okay. So we're going to have essentially our diamond shape, I guess. And we're going to have... Let's make a really awkward kind of collision scenario here. Be very close. Not quite. We need to somehow be able to know to draw a line between here. So we need to be able to somehow get this axis specifically. Because this is probably... Well, not this axis. The normal to that. Normal to that would be... this? But then that should just work, shouldn't it? Because this axis will immediately show us what's going on. So, Okay, so then, if that's not the problem, because it looks like the normal is efficient. If we project onto the normal, there's obviously a gap there. Unless I can find a way to construct a situation such that there is no gap. Actually, we weren't having a problem with the triangle collision, I don't believe. I think we were having a problem with... Or sorry, the rectangle. We were having a problem with the triangle, I think. Yeah, let me just draw it. Let me see. So there is triangle, like so. I mean, the other parts don't really matter too much. And then we're gonna have some obnoxiously close point here. So then why do we have a situation here where this normal is being drawn and it should detect that there's a gap between this point and the bottom edge? Let's go back in the program real quick and see what's not working. So I have given the program the ability to wait a minute. If I move the thing, should I... Maybe I'm not redrawing the convex hull. Maybe that's the issue. So here, the collision is on here, but not here. So immediately I'm saying that the normal on that bottom connection there for the red triangle should immediately disqualify any collision detection. And that should happen. I mean, that might happen near the end of the check, but it should still happen. So we shouldn't be seeing collision at all. I don't know if there is an issue with redrawing the convex hull somehow, but it doesn't appear to be, because the convex hull looks like it's behaving well. Up until I get here. And the funny thing is, it looks like it's detecting a collision where the old Well, maybe not. I thought it would look like where the old lines were being drawn. So, the edge of my collision detection range is where? Oh, now the collision is stuck on and the program has slowed down. What's up with that? There's some weird... it's not a memory leak, because otherwise this thing would have shut down, but some sort of... something is going on in the background somehow that is slowing everything down. Something's being triggered to the point where I can't even go back to not detecting a collision. So let's try to fix that or figure that out. So let's try to learn from our mistakes. I keep going back to the logic of the collision detection, but every time I question it, I keep coming back to the idea that, hey, this looks like it's kind of working. So the number of points has been changed to 3 for this guy. Alright. These points I'll check out. Okay, this works out. I like this. I like this. So... So, okay, so the drawing commands, I feel, are fine. And then we're literally just calling separate 2D with these two fields. And either we're colliding or we're not. And there's these additional print statements, but I mean, they're not even doing anything right now. Wipe them out and just keep one as a template. Hey, we got someone else in stream. Say hi, whoever you are. So, yeah. Something is happening to increase the complexity very quickly, and then it won't go back to where it was before. I don't think these loops are defined by the number of points, and they're all, you know, they're not complex at all. They can't grow. The only thing that can grow here, really, appears to be separate 2D. Because that will grow with the number of connections. Okay. Well, let me just grab this and move this down here. It's my test function. Here, let me take a quick 2-minute break, and then I'll see if I can't figure something out. In the meantime, I'll let everyone stare at the separate confinement algorithm, or at least a portion of it. Here. And maybe someone will come up with something if they pop into the stream. I will be right back. Okay. I'm assuming no one came up with anything because there's hardly anyone in chat. So, it's up to me. Okay, what can we do here? So, we have field 1, field 2. Getting convex hulls. We already trust the convex hull, right? So, we have defined our... Okay, so we're finding the first element of connections, writing that to start con, so start connection. So if we find out that number of okay, yeah, that follows. So if we find out that our connection is the same as the initial one, then what we'll say is that let's say whatever number we're on should be subtracted by 1. I'm not sure if this bothers me somehow. It doesn't rub me the right way because we're treating numline as the actual count, and we're treating this like kind of like it looks like an index. So let's say we go from we start at 1. As long as let's say we got a bunch of lines, we start 1. We find out if index 1 is the same as index 0, essentially, then that means number of lines is 0. And okay, that follows. So if index 1 checks out and then we go to index 2 and that happens, this second element or element number 2 of connection is the same as the initial, that means we should only have 1 line, so 2 minus 1 is 1. This checks out, therefore this checks out. So that's not it. Loop through each line segment on field 1 and get the normal. Okay. So we get... Okay, we address the starting value or the starting address of connections, and we go up by however many units. Okay, so we get the coordinate for connection 1, connection 2, multiplied by 2 to be able to modify vertices, so this kind of checks out. And that'll write to normal and scaled. We're going to project down onto the scaled. Maybe the scaled is the issue, but I doubt it. I sincerely doubt it. Because it should just map. But, what do we... So we have... Oh, project 1D. We should probably check up on that. So we have field 1, and we're projecting it onto the scaled... Okay, so scaled normal, so we're projecting it onto that normal. So we really should have a... Okay. Well, first off, let's go back. What's extent? Okay, so extent is the minimum maximum value we can get. So if maximum... Okay, if the minimum extent is greater than... Wait. No. Okay, so if we find a difference between the two extents, we'll return false there. So if in this case this is the let me write down the notes here. So if the minimum of field 1 is greater than max of field 2, no collision because there's a gap. And similarly, same thing but backwards. Minimum field 2 is greater than max of field 1. No collision because there's a gap. That kind of checks all the boxes there. So it should work. It really should work. Okay, so we loop through each line segment on field 2. And let me add in these comments. And I'm wondering if there's just something missing or something weird that's causing this to happen. We have our scale, we get our normals, field 2. This all checks out. This all looks like it should work. And I honestly can't figure out why... Is it just a triangular case? If I add in another point but make it an internal point, will that also register the wrong result? Or is it because I'm moving around that one point and not several? So first off, let's go back up here and see if we can trigger a false collision by moving the whole shape. Okay, so what do we have? We have square not colliding with triangle. We move it up. Not triggering a collision. Now we're triggering collision. Not colliding. Not colliding. Colliding, not colliding. Okay, so this behavior feels perfect to me. So then why is it that when we were moving just 1 point, that somehow is causing the problem? Is something different happening when we're moving that 1 point, logically, than when we're moving 2? I mean, as is, this feels like it works, because we don't have this issue here. Maybe if I... let me reset the point to the point where it's actually a problem. So, whichever the top left point of the first field is, let us move it to just a hair below the center line here. So, what's the vertical center line? 150? 150, and then center is 100, so let's do 149. Whoops. Come on, 149. Vertical 100. Oh, wait, do I have that backwards? No, 149Y, 100X. And I will probably... Well, hopefully I'll see what was happening when I was moving 1 point and not several. It is a collision, although it shouldn't be. And it continues to be a collision. Except down here. But now... Okay, so it's not because I'm moving 1 point, it's because of something to do with me not checking... Maybe it's me not checking the normals on one shape rather than the other. It's not colliding here, it's colliding here. What if I reverse the order on the 2 fields on the collision check? Will that change behavior? It shouldn't. Where is it? Okay, so instead of field 1 and 2, let's do field 2 and 1. Oops. Okay, let me switch back over to Metafin. Still says it's collision. Okay, identical behavior. So it's not a problem with symmetry. So then is it a problem with... well, if it's not a problem with symmetry, that means it's not a problem with which normals are getting checked. Because in that case, both normals have to be getting checked if they're both acting the same way when we flip the order. See, this behavior works out well. I like this behavior. This behavior over here still kind of works out well. The only thing that doesn't work out is when we're down here. So what is going on here? The normal responsible for detecting collision is this last line. This line from point... I'm actually not sure which points are going here. So from the rightmost point to the leftmost point on the bottom of the convex hull, it should be what? Well, let's go double check and just see. Something weird is definitely going on. And maybe it's not checking the very last the last connection. Oh, that might actually be it. It might not be checking the last connection, huh? So, thing is, this logic does check out. So if we have no... basically, if all points are involved in the convex hull, so we have as many connections as we have lines, what does that mean for us? That means, at best, number of lines can be... Okay, so this check will never trigger, so number of lines can at best be number of points. So we should be able to probe all connections if that's what's going on. So then what should we be reading? We should be reading 4 for the first shape, the square, and 3 for the second shape. So let's check that. Let's actually check to see if we're reading that exactly. So let's let me copy this print statement here. Shove it in here, and we'll just check for a number of lines. Num line 1, num line 2 to fixed. This is an integer. And okay. So that should be able to print out. Yeah, that should work. That should print out. So let's test that out, and we'll see how many lines we're actually probing. Oh, come on, Sigwin. See how many lines we're actually probing. If for some reason these numbers are not 3 and 4, then we have a problem. But it should be 3 and 4. And it is 3 and 4. So it looks like we're testing. I think we're testing. Okay, so let's call this the last collision. So that I'm assuming that's the last thing that we're checking. So are we actually checking that? Are we checking the connection between the very last... Oh! We're not checking the last line. That's it. It has to be it. So, here's what we're doing. We're getting the normals for num line... because this is the same exception I made over here, there. Draw last line. That's a special exception. It has to be handled. But we're not handling it. What we're doing is we're going up to... From 0 to number of line, we're checking the connection between those two. We have to check one more line. We have to check from the final connection to connection 0. So here's how we're going to do that. We have to, okay, loop through each line segment on field 1, and that will get, once we get up to less than or equal to, get normal. Okay, and then if I is equal to num line 1, then we're gonna change what the code does. Else Well, else what we were doing before. So we're going to add an exception for numline 1, and it's going to be, what? It's going to be going from connections plus, in this case, I is going to be equal to numline. So let's just force it already. Numline 1 to 0. Okay, and that's going to give us the... Okay, so this is taking an addresses input for the 2D coordinate. Okay, so that means this should check out. So if we plop it into where? Get normal over here, and instead of doing field 1, we're doing field 2, and that's the only difference. Field 2 and numline 2. So let me just do a quick find replace inside of here. So field 1 to field 2 restricted within the selection. Did it work? Field 2, field 2, field 2, field 2, and we didn't fix this one up here. Okay, good. So let's try that. See if we fix that glaring oversight. Oof. Oh no. Oh, I know what we forgot to fix. We forgot to fix one. We forgot to fix this. This over here. This needs to be less than or equal to, because the second shape is what's getting probed there. The second shape was not getting that last connection, so now it will. Collision. Seriously? How is it still not working? Oh, it's colliding. How is this a collision? Seriously? That hardly makes any sense at all. Come on. And this is a collision. Are we just... Are we somehow checking even fewer? Because this was not a collision earlier. So in order for that to be true, something can't make something collision. You can only make something not a collision using this algorithm. So if this is a collision now and it wasn't before, that means we're somehow losing one of the checks. That's not good. Huh. Okay. So, are we going to the right locations in memory? It looks as if we are. If I is not numline 2, then we are doing the normal check, and that is going to wherever connections are. I thought that was it. I thought that was what was going to fix it. Do we have a print statement here? Numline 1 and 2. Okay. Did it actually come out? We did spit out 3 and 4, did we not? So if we're spitting out 3 and 4, that means we're checking 3 and 4. So we're checking 7 lines total. We should be checking 7 normals. Somehow, this last guy is not doing his job. Let us Let's actually print out what's going on here. So, here, I'm going to print out the coordinate for, or not the coordinate, I'm going to print out the labeled connection for, what? So this will be whatever connection is the last connection, and this should be whatever connection is the first connection. That's what we should be probing. And we're going to do something similar down over in loop 2. Okay. And then line 2. And this will be on line 2. We're going to find out which points we should be probing. So if we're getting to this check, we should be probing the right points. So we're probing points 0 and 2. That doesn't really... does that follow? 0 and 2 for the first shape, 0 and 1 for the second. So, apparently, point number 2 is the leftmost point for the first shape, and point number 1 is the leftmost shape for the second shape. And in both instances, the initial shape is the final connection, making it the one closest on the bottom side of the hull to the leftmost shape. So let's check that assertion. So going over here. Okay. So for the first shape, we said basically the last point before we loop back around is going to be our initial. So we're saying this one should be the closest on the bottom side of the hull to our leftmost point. First off, what's our leftmost point? Leftmost point should be point number 1. And that is not what we saw. We saw point number 1 didn't even come up. So if we let me drag this back in here. See, for the first shape, remember that we're drawing, or where's that? The draw command's not here. Draw command is here. In loop 1. There. We're taking field 1, connections, number of lines 1. And this should give us the connection, the last connection before we get back to the start. And the second one should be the connection where we go back to the start. So the start should be the leftmost. It should be the extreme. It should be the one with the least x. So looking at this, the one with the least x is either point number 1 or point number... No, it's just point number 1. That's the only option. Point number 1 isn't even present. Point number 1 should be where number 2 is right now. Oh wait, did we flip the logic some? Oh yeah, we flipped the logic. My bad. Okay, let's rerun this. Thought I found something. Okay, so point number 1 is where it should be, and that means point number 0 is the last point before we get back to point number 1. Point number 0 in this case should be, for this specific case, should be the one with the least y. So point number 0 has 149, so it's actually the tallest point. And then we have point number 1, point number 2. You know what? Something weird is going on here. What are we doing? Let's print the connections. So I'll do star field 1 dot connections plus 2 times, 3? No, let's do connections one at a time. So it's going to be plus 0. How many points does field 1 have? 4, right? 1, 2, 3. And let's just start on line 3, 4. Oh, I forgot to reset Mendefin. Let's try to do that. Okay. So now we should be printing out all the connections in field 1. I want to see what they actually are. So, okay, we have, we go from point number 1 to point 0 to point 2 to point 3. So that means the last point we should be going from point 3 back to point 0, not point 1 to point 0. Somehow that's not being communicated. So let's figure out what's going on here. So in this case, let's see. Whoops. Okay, let's actually share the code here. So, let's get rid of this music. Yeah, close enough. Okay. So, numline 1. This should modify connections to go from the 0th one to the one that we care about. Unless... maybe it should be numline -1? No. Because if we have one line, that means connection 0 is their initial point, connection 1 is our final point. So, no, numline should address that. And recall that we were getting 0 and 2, or is it 0 and 2 or 0 and 1? Either way, we should be getting 3, and 3 was... Yeah, both of these are not returning the right thing, which leads me to believe that we're not getting... What are we not getting? So yeah, so let's see, if there are no connections, then number of lines is going to be 0. Field connections, we're going to address the first one. So yeah, this all checks out mathematically. This should work. Let's run this again, just double check. Make sure I'm not going crazy. Okay. The first print statement is saying what? We are saying that our final point. Let's look over here. So the first thing is our final point. The last portion on that first line is our starting connection. So it's saying our starting connection is point number 1 and our final connection is point number 0. So let's just go up real quick to our points just to double check. Our starting connection should be point number 1 and our ending connection should be point number 3. So neither of those appear to be correct. Wait, so 0 and 1. So, okay, just double check. First thing that gets printed is the final connection. Second thing that gets printed is the initial. So we're saying that the initial is 1. So the initial being 1 checks out. That's what that is right there. And then 0 is being evaluated here. Oh, okay, wait. I was looking at the Y the whole time. So yes, this 0 being the extreme point also checks out. So going from 0 to 1 should check out. But then we look at our actual connections here in order. You go from 1 to 0, 0 to 2, 2 to 3, then we should be going from 3 to 0. 3 to 0 should be our final check, and I suspect 3 to 0 is not the final, is not being actually checked. Or sorry, not 3 to 0, 3 to 1. We should be going from 3 to 1. So why, if we know that a connection index 3. So connection index 3 is actually 3. That checks out. So connection index 3 is actually 3, then what's going on over here? We should be going from the maybe this is num line -1. And num line 1 greater than 0, just as a sanity check real quick. Then this would be what? I'm just trying to figure out if this is actually the right way of doing this now. So if we, in this case, we have 4 lines total, right? And that would indicate that we had 4 unique connections before we started looping back on ourselves. So if we added 4 to the 0 index, we'd go from 0 to index 4. So this needs to be -1, which I think I talked myself out of earlier, which is bad. So this should also be a -1. So this is an off by 1 error, it looks like. So let's retry that. Oh, come on, Sigwin. Don't be that guy. So we should be going from, what was it, 0.3 to 0.1 is our final check, correct? What is going on? We've frozen the program. How did we freeze the program? Okay, apparently the last print statement to check out was 0 to 1. So huh. So we print out, what are we printing out? Where are my print statements actually? Here. So lines 3 and 4 don't get to print, which means we're getting locked up somewhere in separate 2D. We're separate 2D. Where are we printing in separate 2D? Where do we know that we can print? We can print this line. Somehow something's getting messed up over here. So, okay, this won't trigger unless number line is greater than 1. Should be fine. So if I have if I have 4 lines, right? So that's connection from first point to second point, second to third, and third to fourth. So I want to access the third connection. Wait, no, the connections are the labeled points. So first connection is going to be our initial point. Second connection is going to define a line. So then is num lines wrong? Hmm. Okay, first off, let's initialize number of lines as 0. Okay, now we're gonna start. Okay, we already defined our starting connection. So if starting connection is equal to the connection that we're probing, that means whatever index we're on is not a valid connection line. So. So now I'm trying to think. Okay, let's say we have at least 2 points. Then, if the starting connection is different from the initial connection, what will this return? This will return 0 lines. That sounds incorrect. I believe this should be 1. And to prevent some weirdness, we should also include in this if statement whether the number of points is greater than 1. And can we access number of points? Where is it? Doesn't look like I actually access it though. That's the thing. So I don't want to access it weird. Let's just try this. Field 1. Field, okay, and this is going to be NB point greater than 0. Well, that should be field 1, not field 2. Okay. And then field 2. Oh, here's the check down here. Let's just copy this whole thing then. There. All right. Oh, okay. This is not gonna. Oh, this is not gonna to end well. So what I'm gonna have to do is I'm gonna have to move up the number of points back up to here, and then something similar over here, except with a 2 instead of a 1. So if we do end up saying that whatever connection we're on is the same as the initial, we're still gonna write that number of lines. So what happens if this check never actually happens? So all points are unique. So then what we're going to have is what? We're going to have... say we have 4 points, so indices 0 through 3. So number of points is registers 4, so we will get I up to 3. Once we get I equal 3, without this check here... Without this check... Oh, hey, someone else is in chat. Hey. Right now, I'm trying to fix my collision algorithm by checking to see if somehow I'm not probing all the lines that I need to be probing to compare two different 2D shapes. So, right now, I'm having trouble trying to figure out how to get this loop to do what I want it to do. I need to loop through all these points, And if I see repetitive connection, I need to cut it off early. Oh, I know. I can take this line and move it outside the loop. Whoops. So whatever I becomes, I will set that. But that means, crap. Oh, let's move this outside the actual if statement. Okay. So I'm just gonna iterate numLine. And then if I say... This is going to be an OR now. So if number of points is 0, I'm going to break. Or if whatever connection I'm on becomes a starting connection, I'm also going to break. So, well... Okay, we're going to split this check up into two. So we're going to do, if number of points is 0, we're just going to break out of the loop, and then we're not even going to set numLine to anything besides 0. After the loop, or after this one line, if the starting connection is the same as the field connection, then we're also going to break. But that's after we set numLine is equal to I. And that should do it, I want to say. Let's try this again, but with 2 instead of 1, because we have to do it for both shapes. So, first check. Are there actually more than... are there more than 1 point on this thing? Is there more than... Is there at least 2 points? If so, you can keep going. If not, if you can only find 1 point or less... Here, let's try this. Less than 2. If there are less than 2 points, we can't really draw a line, so we gotta break out. And number of lines remain 0. There's at least 2 lines, 2 points, then we can at least say that... We can at least say there's 1 line. Crap. Okay, so it's going to be either this, or... There's going to be another OR statement. We have to take care of the idea that if we have the first point and the second point or the second connection, there is no line. There's just a dot. So if we had a field with 2 identical points, we still can't draw a line. So, let's do... Let's do this. Let's do... oh, this should be a 2. Or field connection I should be... if that's equal to field connection I minus 1. So essentially, if the previous connection is equal to the same connection, then we can break already. And when this is going to come up is if... basically, the only time this really should come up is if we're on the second point and the first point is identical to the second point. And by that I mean index 1 reads the same as index 0. Let's try that. And then we'll do this, except find replace... well, I'll just do it manually. It's close enough. All the 2s are now 1s. I feel like I'm overcomplicating this logic, but this is the only way I can make sure it's doing what I want it to do. Okay, so now I'm kind of satisfied that we're probing the right connections. We're getting the right number of lines at the very least. So in this case, this line count is now counting the the final connection. So the connection from the final point to the initial point to close the shape. In this case, once we get to number line and we know that number of lines is greater than 0, then we can do that. Let's see, is this right? So if we have one line and we're connecting, so let's say we have a square. We're gonna have 4 lines. And that means we're also gonna have 4 connection points. So we go from, let's just say we're going from 0, 1, 2, 3, 4. That means we want to access index 4, which also happens to be the number of lines. So we don't want this -1 anymore. So I thought I talked myself out of that earlier, and then I untalked myself out of it, and now I have to re-talk myself out of it? I don't know. I feel like this is the right index. Okay, let's see with those changes made to see if this actually worked. I like that. Oh. Okay, so we see we're going from 3 to 1, like we were not before. And, crap. I got excited too early. Somehow this is a collision. That it really shouldn't be. This should not be a collision. I don't know if there's a miscommunication between field 2 and 1. This shouldn't be a collision. This should not even come close to being a collision. I don't know what's going on there. But at least what I know is happening is that field 2's bottom line, the last line to be connected from the last connection point to the first connection point, is checking because that's the axis responsible for making sure these guys do not touch. However, who would be responsible? Who would be responsible? Be what, the first line on the? Actually, we can check. Who's the leftmost point? Leftmost point should be point number 3. So point number 3 going to point number no. Point number 3 going to point number 1, it appears, right? Because we start at point no, point number 1 is the leftmost. Is it not? Yeah, point number 1 is the leftmost, then we go from point 1 to 0, 2, 3. So 0 would be the highest point, and then 2 would be the midpoint, and then 3 would be the low point on the right side of that blue triangle. So then the connection between 1 and 0 appears not to be doing its job. Also, things are slowing down. What's up with that? Doesn't make sense for a connection between 1 and 0 not to be doing their job. Oh, hey, whoever popped in. Right now, I'm trying to fix my collision algorithm. This thing just kind of broke itself in mid-use. That doesn't make any sense. So, we're using our separating axis theorem to try and figure out if 2 shapes are colliding, 2 polygons at least. However, this thing is not cooperating. So, let's see. Let's look at number 1. We have... Are we getting... Is this getting normal? This isn't... Oh yeah, we are getting the normal. Getting the normal, we're even printing it out. Wait a minute. Okay, yeah. That's fine. We're getting normals, we're printing them out. So this is for the last one. Okay, that checks out. And otherwise, we're just doing the normal just iteration. And we're doing something similar over here, right? Comparing the extent still checks out. So we're comparing minimum, maximum for both ends. Projections, those look like they're working. Or most of the collisions wouldn't have worked anyway. So then... what is causing... okay, first off, the worst case scenario is that the collision is happening, meaning that we have to loop through all the stuff. So that's the slowest this program should be able to run. Projections should be basically fixed cost. That should be a problem. The unit vector should be basically fixed cost. That also should be a problem. So we're doing all those things just basically once. Well, not once per loop. The loop size isn't growing at all. At least it shouldn't be, because the points are not moving in relation to each other. So, what are we doing? Why is I fix one aspect collision, another aspect breaks. For some reason, the very first line that gets drawn for shape 1 doesn't seem to be doing its job. So let's see. Maybe I mixed up 1s and 2s when I was copying code over. Let's see, this is all 1s over here, right? Up top, and all 2s down below. Alright, so what's up with that? You know what? I'm not sure I'm comfortable with allocating memory this way. Let me see if I break the program just doing this. If this doesn't break the program, then I should replace them all, because I think maybe the memory leak is the issue. Maybe I'm slowly causing a memory leak and it's just screwing things up. Well, I like that. So let's replace all those. I mean, in general, you probably shouldn't malloc in a function that you're calling over and over and over and over again, because that malloc stuff I don't believe goes away over here. So yeah, I've replaced the mallocs. Here, I'll show you. So this mallocs, there are 4 of these, and I'm replacing them with just 2s, and apparently, so that should just work. It'd be really stupid if this is what was causing the issues on that collision test. Really hope it wasn't. Okay, this looks like this. Okay, there we go. So the behavior is still wrong, but in very specific situations. Here, this. So the axis responsible for detecting this collision should be, I believe, from 1 to 0. So going from 1 to 0, we should have a normal being drawn that is projecting stuff down onto it and saying, hey, this stuff is not colliding. Oh, and then the axis over here should be from 0 to 2 or 2 to 3, whichever, you know, ladies pick. Then over here, it should be field 2's axis should detect this collision. So somehow a lot of things are being skipped. The first element of field 2 is not detecting a collision properly. First element of field 1 is not detecting collision properly. Last elements appear to be detecting collision properly, which is why blue's last element is that diagonal, and it's telling me I'm not colliding with any of these guys over here. Red's last element is the bottom, so if I'm below anywhere, I'm not colliding. But once I cross that line... am I only checking the last elements? Is that what's going on? It certainly looks like I'm only checking the last elements, now that I think about it. Let's see if that was it. Let's see. Okay, so let's loop through every line segment and see what we get. Starting with 0. Okay. If I is equal to num line, so that this is the last check, and num line is greater than 0. So yeah, this should. So basically, this should only trigger like once, ever, the very last time. Otherwise, we're doing this, and then I should be able to go from 0 to 1 or 1 to 2, etc., etc. This should not be the issue. This should be writing normal and scaled. And then the extent checks are what they are. Somehow, are we not... Did we need to malloc that? Is that the issue? That doesn't make too much sense, because at the very least something is getting written to normal. Because otherwise we wouldn't be able to do that. So that can't be the issue. I mean, what I could do is I could try to pass by value. Just for the projection program, I could do scale X, scale Y. Maybe that'll trigger something. I don't think that's it though. The extents appear to be working correctly. Because otherwise, none of this could possibly work with these. So I don't think it's a memory issue the way I'm thinking of it. What could it be? Huh. It looks like I'm only checking the very last lines. The things that I input over here. But it's not a symmetry thing, because both of the last lines appear to be doing their checks, but none of the other lines appear to be doing their checks. This else doesn't ever seem to be triggered. So what's up with that? Maybe I can enforce this somehow. Okay. So if number of lines is... Well, if number of lines is 0, and I's only ever going to get the chance to be 0, so then this is actually kind of redundant. I don't need to do this. What I can do is if I is less than number of lines, and I'm going to swap these two. And I don't think I need these print statements anymore. So here, let's swap these two. All right. If I is less than number line. There we go. It's most of the time that's going to be true. Okay, field 1, verts, and then we're just giving it an address here. That's all we're doing. 2 times. Why are we doing 2 times? Is there a reason for that? Yes, because verts has 2 elements. Okay, there we go. Connections. So the initial connection plus however many units we're on. Okay, so if we start at 0, we're going to check 0, and then we're going to compare it to 1. Wait a minute. So... So if there's 1 line... Well, if there's 0 lines, this is going to just break. Okay, so this will never trigger anyway, because it has to be this. Of course, there's no normal you can draw with a 0, 0. But yeah, I'm not even going to worry about that. I'm not going to worry about the single point case. I'm going to worry about just normal behavior, because that's what we're having a problem with. So we started 0, so we're comparing connection 0 to connection 1. We're drawing the normal via scaled. The projection should just be working as the projection should. And then we're going to compare the two extents. That should still be working. Let's try this then. Less than 2. And then this is going to be... Yeah, let's just find replace real quick. Field 1, replace with field 2 within selection. Okay. Anything else? Numline 2. Now, logically, I don't think I've changed anything really, so it should... This shouldn't really fix it. Not colliding, okay. Hey. Did that fix it? Really? That is stupid that is what fixed it. Huh. Well, okay, I mean, that's what fixed it. Just switching the logical order there. I guess something in that check was just... Maybe it was an and instead of an or. I don't even remember. But this appears to be working. Convex hull is fixed. Separate axis in 2D is fixed. We can try a stress test now, I guess. Here. Let me take a 2 or 3 minute break, and then I'm going to try some stress tests. But I've kind of done what I set out to do today. I mean, we could try to get started on 3D if some people want to file into the stream, but I don't think anyone's on tonight. I think something special going on this Friday or something. End of the month type deal. I don't know. Be back in a couple minutes. Okay, back, and just in time to get rid of this kind of... Well, it's not the worst background music, but I'm going to skip it. I want something a little bit more... There we go. Every time I complain about the energy of the music, I always end up back on Sonic Colors, and it's not a bad transition, at least not for me. So yeah, let's stress test this guy. Remember when we had like Brazilian points? Let's do that. Let's go back to 4. 4 and 4. Alright. Come on, Sigwin. Don't be that guy. Collision, not colliding. Collision, not colliding. Yeah, it's acting as it should. I think all sides are finally being checked. Points are doing what they do. Oh, let's go back to the part where I'm only moving 1 point at a time. I think I can move all the blue points down by 50 and be good. So let me do that. So blue points. These guys are high up. Let's get these guys lower down. Let's do. You can be like 50 for all I care. 50, 50, be 0. That's a bit aggressive. Okay, let's do 75, 75, and then last point can free float by setting all these guys to 0. And this should stress the well, it's gonna stress it in a theoretical way. The programmatic complexity hasn't changed at all. So the computer isn't working any harder. It's just that I'm just testing different scenarios now. Not colliding. Those weird pink boundaries. That's new. I don't know why that's happening. But I'm not going to be drawing things in the background like this during the real game anyway. So, oh, I like how the convex hull is evolving when I'm moving stuff. Oh. And it's working in a way I like this. Like this is basically perfect. It's kind of sad that the chat is so dead tonight because this is a much more victorious moment than when I figured this out the first time and kind of had it working. Now I really have it working. All right, so I mean, considering I've done what I've set out to do today, I'm planning on doing another stream on Thursday night if I can, just to kind of round things out. So news: I am going to be visiting Albuquerque for work for about a month, and it's definitely going to interrupt the streaming schedule significantly. I'll bring my laptop with me and I'll see if I can't stream with my laptop and see how well that works out. If not, I might have to take a 1 month hiatus. Also, that means next Friday I'm going to be driving, so I'm not going to be streaming, so I'm going to try to do one Thursday. Maybe I'll do like a quick video game stream during the week, I don't know. Just for funsies. So right now we have a competent 2D collision system, and all we need to do to make this from a 2D collision system into a 3D collision system is to just collapse it, just to project down from 3D to 2D, which is just another vector. We're just taking another inner product, really, and going from 3D to 2D, we should be able to just plug these 2D points into the field 2D and run the same algorithm and come out with the same results. And the only problem is we have to do the same way that we're looping through all of these lines. So I've got 2 lines and then 3 lines and then 2 lines and then 3 lines. Or sorry, 3 lines and then 4, 3 and 4. The same way that we're doing that, we have to do that with the faces of the mesh, or not the mesh, but you know the 3D collection of quads that we have. So this might end up getting rather expensive if we don't have a good culling algorithm for this. But at least in my application, I'm not planning on having a lot of physically interacting objects. I just needed something where I could have a bare bones algorithm that I'm sure will work with an arbitrary kind of shaped environment. So if I wanted to walk up a slope or run into an odd-shaped object, I should be able to do that without having to do bounding boxes, which I feel are a lot more clunky and awkward. I don't really like them, even though during this era of video game design, they were probably a lot more common than what I'm giving credit for. This is probably a very programmatically, or not programmatic, very processor-intensive, memory-intensive approach to, maybe not memory-intensive, but at least very processor-intensive approach to detecting collision. And I feel like in a proper platformer, this would definitely slow things down. Same thing in a first-person shooter, but I plan on having the environments. I plan on being strategic enough with my level design so that this shouldn't be an issue. But we'll see how bad it turns into when I convert this over to a 3D. So yeah, maybe I'll see you guys in. Maybe I'll see you guys later this weekend. I don't know. Maybe I'll do another game stream, because I've been having fun with the one or two I've done already. More likely than not, I'll see you guys on Thursday when I do my last Collision stream. Hopefully this will be the end of the month of Collision, because it's already been 2 months and we're almost done. So I guess that's about it. So I'll see you guys next time.